this is number 3 on the 14.2 homework, and here we're using a regression model that they actually already give us here. They give us the least squares regression equation right here, and we're using it to predict the mean value if x is 1.9, right? And we're also using it to predict a single value, the single y for a 1.9 input. Okay, and those two things end up being the same. And it's tough to wrap your mind around what's the difference of those two things. The first one is just saying that, if I put in 1.9 a whole bunch of times, right, and I took the average of all the outcomes, all the y values that come up when I put 1.9 in, when I select that as, when I get a bunch of data points with 1.9 as an x, and I average all the y values, I should get 5.4, or that's what my model predicts, right? And the other one is saying, well, if you had just if somebody asked you, well, what y would you get if you put 1.9 in, if you just had the, for a single shot of one thing, right, you put in 1.9, what would you predict you get out as a y? And it ends up being the same thing, 5.4, okay? But it's two different ways of looking at it. That's going to have implications not in terms of the prediction part of it. You're going to, if we put in 1.9, we get 5.4 for both of those, but it will for the confidence intervals. The reason is that when we're averaging a bunch of data that has 1.9 as an x, and we're just averaging the y's, we get a much smaller standard deviation. We get a much smaller standard deviation. And so the confidence interval is smaller, right? We don't need as big an interval to have a 95% confidence. When we're doing the mean, we're doing it as a mean, as whether we're doing it as just a single point prediction. So let me show you how to get those in StatCrunch. So I'm just going to open up the data in StatCrunch. I'm going to copy it. So we can see these side by side. And I'm going to do the regression analysis. So just go stat, regression, simple linear. Okay, x's are in x, y's are in y. Okay, now here's what I'm looking for, prediction of y. So I'm interested when x is 1.9, and I want confidence at a 95% level. Okay. So let me show you this. So here's our, this is the least squares regression line, which we already were given kind of in that little pop-up over here. So we didn't need that. But here we need the confidence intervals. And you're going to have two different confidence intervals down here. So here's the x value, 1.9 that we put in. Here's the predicted y value, rounded to the nearest tenth. That's 5.4, right? And here is the 95% confidence interval for the mean, right? And here's a 95% confidence interval. Well, actually, they call it a prediction interval. It's a confidence interval for just a single prediction, okay? And you notice that this is a 3.2 to 7.5, which is inside this one. It's a smaller confidence interval, around 5.38 than this one is, because the prediction interval, like I said, is just a one-off. It's going to have a lot more variance. The standard deviation of is going to be more when we're just making a one-off prediction, rather than when we're averaging a bunch of the y values together in a sample. So the 95% confidence interval for the mean value is going to be this one right here. Okay, 3, and then once it's rounded to the nearest tenth, 3.2. and then 7.5. Okay, now predict the value of y if x is 1.9. This is the single prediction, right? And it's again 5.4. That doesn't change, from here to here. That prediction and the mean value you'd expect don't change, but the confidence intervals do, just because with this you have more, you have more data and you have a smaller standard deviation, keeping the confidence interval tighter. Okay, so the prediction intervals over here, this 1.8 and then 8.9. Let me just check the answer. It's all good. Okay, so I hope that helped on this question and how to use StatCrunch to get it and why these are different. That's important. That's really important.